JEE and NEET examination. So we'll solve few questions. So daily this 9 to 10 p.m. or 9:30 to 10:30 p.m. I'll come live with new topics. So today we'll discuss about laws of motion. Okay. So laws of motion, as you know, the motion of the three laws of motions are there, and first one is if any object moves or in moving in a uniform motion, then it will continue its motion, or if it is at rest, then it will be at rest without an external force applied on it. Then the second law is all known to you. All of you know the second law of motion, that is F is equal to ma, and the third law of motion, that is every action has a equal and opposite reaction. You know these laws of motion, and also in some problems I have solved how to solve the questions from three body diagram. Using the three body diagram, how you draw different type of problems and pulley problems also. So today we'll solve few questions which is based on the laws of motions. So let us solve one question that one object is kept on a, suppose, on a table like this. An object is kept, okay, and it is a frictionless. We'll come to the friction parts later. So it is a frictionless table, and in this frictionless table, one object is there, and the object mass is also given. The mass of the object is 8 kg. Okay. Now, two more objects are there which are connected through pulleys. Two pulleys are connected here. Okay. And two more masses are hanging like this. One is 4 kg. This is 4 kg. And one more mass which is hanging in the other side is of 2 kg. Right. Now, when this type of problems are there, how you will solve this type of problems? This is very important. Okay. So one 8 kg object is there, which is, let's say, on the table. One mass, that is 4 kg, which is hanging on the other side, and another mass is hanging in the left side. So here, by looking at the diagram, you can say that this object which is on the table will move either towards right or left. You can predict. So your prediction may be wrong, no issue. At the end, you will able to understand that your prediction is right or wrong. You will get a different acceleration. Means if you predict the acceleration, suppose you predicted that acceleration is downward, but in the result after the calculation, if you get that this acceleration is negative, so then you can say this, no, this will go in the upward direction, and this is 8 kg object will go towards the move towards the left side. Okay. So now, as you can see here, that first we'll draw few free body diagrams. First we'll draw some diagrams. Then what we will do? Then we will make the free body diagram and all the forces acting on different objects that we will discuss. So first, let's say this is the object. What will be the masses on this? What will be the forces on this object? So the forces on this object will be, let's say, mg downward, because gravity will pull it to the downward direction. So mg will be downward, and here also mg downward. Let's say this is m1, this is m3, and this is m2, right? So gravity will pull it downward. Now an object is hanging with a string or any thread or spring, then tension force will be there in the upward direction. A string, when there will be a string, there will be a tension force. Okay, there will be a tension. It's a force which will act opposite to the direction of your gravity, means gravity is pulling downward and tension will be in the upward direction. Now here also there will be tension force, right? And as let's say this is T1, and here let's say it should be T2. This is T2 and this will be also T2. Okay. Now you can draw the free body diagram here. So how will you draw the free body diagram for this object? You can draw a free body diagram. Let's say this object is having mass m, and downward direction this is m1g, upward direction you can do it T1, this is T1, this is T2, T2, no issue, means, and this is m1g, this will be T1. Here the mass is here. Okay, but ultimately the acceleration of this object is in the upward direction. The object is moving in upward direction. Acceleration is upward. So remember one thing, if the acceleration is upward, that means our prediction will be that in upward direction more force is there. So we can write the equation T1 minus m1g is 0. Not 0 here, ma is there. Object is moving upward, so ma or m1a. T1 minus m1g is m1a. So one equation done. Okay, now what are the variables here? T1 is a variable, acceleration is a variable. So we need 2 or 3 equations because 3 variables we have to calculate. T2 is a variable. So 3 variables are there. So we need 3 linear equations to solve them. So either by using your substitution, elimination, or cross multiplication, means you can use this method to solve the equations and you can calculate. So first one is first equation is done. This is the free body diagram for the first this side. Now let's concentrate upon the middle one, this mass. So this mass, what will be the free body diagram for this mass? The second one is, this is let's say your mass. So mg will be downward, that is m2g, and a normal force will be upward direction, contact force. If the object is kept on a surface or kept on an object, then there will be a perpendicular normal direction, normal force will be there. So normal force is in the upward direction, m2g is in the downward direction, right? Now T2 is in the right side, T1 in the left side, and the object is ultimately moving towards the right side with acceleration a. Object is going like this, whole system is going like this. 4 kg object going downward, this one going right, and this one is going up. Everything is in the towards the right direction. So as you can see, this is the object, downward direction m2g, upward direction normal force, left T1, right T2, acceleration towards right. Now see, the object is not going upward, so n and m2g are balanced. They will cancel each other. They are balanced force, they are not unbalanced force. So I can write from here that N is equal to M2G. Sometimes it's required, sometimes it's not required. Okay, and friction, it's not, there is no friction between the surface and the object here on the table. So there is no frictional force. So friction is zero. So we'll not bother about the friction. Okay, if there would have been friction, then this N is equal to M2G will have some work there. We'll see in the later examples. So N is equal to M2G, one equation. Now the object is ultimately going towards the right direction. So what I can write? So I can write that T2, the tension force along T2 is more than T1. We can assume the, okay. So we can write the equation that T2 minus T1, this is the net force, this equal to M2A, motion. This is your mass into acceleration. The net force is equal to mass into acceleration. What is the net force on the object? T2 minus T1. T2 minus T1. Okay. Now, two equations at least. This equation, I think it's not required for us. At least two equations are done. Now the third equation, we'll go to the next part, this part, last part. So here again, we'll draw the free body diagram for this object. Now this object, I'll draw M3Z downward and T2 upward tension, and object acceleration is downward. Object is going downward ultimately. So how will you write the equation? The equation will be M3Z minus T2 is equal to M3A. This is weight, force in the downward direction due to the gravity. Okay, and tension is upward. Ultimately, the object is going downward, so we can think that M3G is greater than T2. That's why the object is going downward. More force in the gravity is more than the T2, and acceleration is downward. So that's why you can write M3G minus T2 is the net force, which is equal to mass into acceleration from Newton's law, second law. So now we have three equations. Now our life problem is easy. Now you have three equations in your hand and you need to solve them to find out different quantities. Okay, so now solve the equations. Solving the equations are done. This is the important part. This analysis is the important part in a problems like this type of laws of motion. When the problems are having strings and all these things are connected, then the first important thing is to write the equation. Once you write the equation, it is easy for you to solve it. So now you can put these values of M, because masses are given here, and G you can put 10. Okay, G you can put 9.8 so that you will get good numbers. Put G is equal to 9.8. In the question itself, sometimes they give 9.8 meter per second square. G is equal to, okay, then solve it. So how will you solve it? You can use substitution or any other. So from 1 you can write that T1 minus what is M1? Now 2Z, Z is 9.8, or let's keep it Z. 2Z is equal to 2A. Okay? So this is your equation. Now, what is equation number 2? Equation number 2 is T2 minus T1 is equal to M2A. That means T2 minus T1 is equal to M2A. What is M2? 8. So 8A. Now what I'll do, I can I can add these two equations. So if I'll add T1 minus T1 cancelled out, what will remain? Now T2 minus 2G is equal to 8A plus 2A, 10A. Now I got one more relationship. Let's say this is equation 4. Okay. Now this equation 4 I'll add with again equation 2. Okay. Equation 3. So equation 3 is your M3G minus T2 is equal to M3A. What is M3? 4. 4A. Okay. So this is from equation 3. Okay. So now I'll again add these two equations. So T2 minus T2 cancelled out. What will remain? M3 is 4. So 4G minus 2G, that is 2G, is equal to 10 plus 4, 14A. Or here you can write, okay, so it's not visible. So 4G up to this one it's visible. Okay, 4G minus T2 is this one. So this equation 4G minus 2G, this will become 2G. Okay, 2G, and this will be your 14A. Okay, now you can do it. Okay, that 14A is equal to 2G, that is 9.8, or acceleration, one variable you can calculate. What is acceleration? Acceleration is 2 into 9.8 by 14. So this is 7. You can cut it, cancel. So this will be, let me check the answer. So 7, this is 1.98 to 4. So 1.4 meter per second square. So, and we are getting a positive sign here, very important. We are getting a positive sign here. So positive sign means the predicted direction of acceleration is true. Means we have taken acceleration is downward, because in some cases, on double acceleration case we will discuss, then you will not able to predict the acceleration perfectly. In that case, what will happen? If you are getting, suppose in the result you will get minus, you are getting in a negative sign, that means what? You have predicted the acceleration in this direction, but it's not true. As a result, we are getting negative, means your predicted direction is not true, so the acceleration is upward. Okay. So now what we'll do? Acceleration is done. Now just we'll put the values in either equation and we'll calculate, easy. Okay. Suppose you put here in equation 1, then you can find T1. So acceleration T1, T2, everything can be found now. So from equation 1, you can see that T1 is we are supposed to calculate minus M1G. What is M1? 2. So 2 into 9.8 is equal to M1 is 2, A is 1.4. So T1 is that is 2.8 plus 19.6. Okay, that means 864 and 9 to 11 to 22.4. This is the correct answer. Let me check. Yes, so 22.4 Newton, because tension is also a force. So 22.4 Newton is the tension on the string 1. This is the tension on the string 1. We have taken assumed that this is tension 1. So what is the force on the string? The force on the string will be 22.4 Newton. Now easily you can calculate it too from equation 3rd or equation 2, any equation you can use. So let me use equation 3. So from equation 3, your M3G, that is 4 into 9.8 minus T2, T2 is separate, keep it T2, and M3, that is 4 into A is, we have already calculated. Okay. Now we will calculate T2. Just bring it here. So 4 into 9.8 plus 4 into 1.4, sorry, minus. This I'll bring left side. So T2 I'll take right side. This will become plus T2. Okay. Now, if I'll subtract 4, 9.8 minus 1.4 is equal to T2, or you can write this is 4 into 9.8 minus 1.4. This is 4 and 8.4 is equal to T2. This is equal to 6, 4 8 is 32, 33, 33.6 Newton. So this is your T2. So now we got all the values, right? So we got all the values that we got acceleration is equal to 1.4 meter per second square. We got tension 1, 22.4 Newton. We got T2 is equal to 33.6 Newton. So when this type of questions will be asked, you need to solve this type of equations using free body diagram. First, your task is to draw the diagram for different sections, for different objects. Okay. So then from these objects, you have to predict the acceleration and you have to write the equations. Once you write the equations, these 3 equations we have written here, n is equal to m2z is not useful here. It's not useful. So sometimes it will be useful. So here what you can see that these equations you will use your substitution or elimination method to solve these equations and find out the accelerations and the tension and other quantities. Okay. So in this way you have to solve your laws of motion problems. So in the next class, that may be tomorrow, same 9:30 or 9 p.m. we'll discuss some problems based on friction. That means here we have used, it's a frictionless surface. Here we have used frictionless. There is no friction between this object and the surface. But if there will be friction, then friction will appear in the, if object is moving right side, then friction will to the left side, and we'll use the formula for friction. Okay, that relationship we'll use. So for today, let us stop here with this question. Tomorrow, we'll try to solve few more questions. Thank you. Let me end the stream here.